Hello guys, welcome to our YouTube channel High Speed Board Design. Today we are going to discuss about the component placements in PCB. This is the first chapter of the series in which we are going to discuss about the power inductors, how the power inductors need to be placed whenever we are using a switching mode power supply, that is SMPS, or a DC-DC converter. So in the setup of a DC-DC converter, you may notice there is this DC-DC converter, and after the DC-DC converter we usually use an inductor. So this is the output inductor that we usually use. So in today's lecture, we are going to discuss about the placement guidelines for this inductor. So this part has been requested by one of our subscribers. So let us quickly discuss about what are the placement guidelines for an power inductor and what are the factors that affect the power inductor placement. So in today's lecture, we are going to discuss about the guidelines for placement of inductor, how the wiring area of the inductor plays a major role in reducing the EMI. When talk about the wiring area, I talk about the power plane that is being used between the first pad of the inductor to the SMPS. So how we are going to design that part in order to reduce the EMI. The third point is the ground layer and placement of inductors, how we are going to place our ground layer. And the fourth point is inductor pads placement. So how the area of the pads play a major role in the proper operation of the output inductor. Let us quickly jump on to the next slide. So let us quickly discuss about the placement and wiring area for the inductors. So whenever we are using the inductor as an output inductor in case of an SMPS or DC to DC converter, as in my examples, you will notice this is my DC-DC converter. This is my switching mode power supply. These Couts are my output capacitors as well as my decaps, and L is something which I call output inductor. These are the output power inductors. So the major role that output power inductor does is whenever there is a SMPS, as you can see here, SMPS to load. So there is this SMPS, there is this load. So whenever load requires energy instantaneously, that is being discharged not directly from the SMPS, it is being discharged from the inductor which is being connected. So the guideline says you need to put this output inductor nearest to the SMPS, that is switching mode power supply. You need to put this inductor nearest to the switching mode power supply. Now let us talk about the wiring area to reduce the EMI losses. So as you notice, this is example A and this is example B, and there is one difference between both the examples, that is the wiring. The kind of wiring that we have done for both the examples is kind of different wirings. So it is always advisable the copper foil should not increase beyond what is necessary. That means the pad that is connected, the power plane that is being connected between the SMPS and the inductor should not be very large, as well as it should not be very small. It should be precise and it should not be more than what is necessary. Okay, the main reason behind this is the wiring resistance. So what wiring resistance does? So there is this concept called wiring resistance. So once the wiring resistance increases, the heat dissipation also increases. The heat dissipation also increases. So this power plane usually act as an antenna and may cause increase in the EMI. So in order to reduce the EMI losses, it is always advisable to design your power plane in such a way so that it is not too much and the amount of copper need to be used is limited. Till now we have discussed two things. One is the placement of the power inductor and the second is the wiring area, and this can help us to reduce the EMI losses. Now let us move on to the next point. So the next point states that the ground layer placement should not be located directly below the inductor. So as I have taken two exhibits, exhibit A and exhibit B. In exhibit A, you will notice there is this output inductor that I am using, and there is this ground plane which is going just a layer below the inductor. It is always advised not to use the ground plane below the inductor pads. Why is it so? Because there will be cancelling of magnetic forces caused by the eddy current. So the ground plane usually have eddy currents, and because of that, magnetic field which is being created in the inductor will be cancelled out, and once it gets cancelled out, the inductor value drops and the losses increases. So if whenever we require the amount of energy in the inductor to be held, that amount of energy will be lost, and once that energy is lost, then whenever a load is requiring more amount of energy, at that time you won't be able to give that energy at all. We should not use a ground plane or any plane for a matter under the pads of the inductor. So this may increase the losses as well as the operation of the inductor. The last point that we are going to discuss in today's lecture is the inductor pads placement. By saying the inductor pad placement, you will notice there is this two examples. I'm using the same examples again and again just to give you an idea how the placement is being done. So in the first example, you will notice these pads are there, the inductor pads, and in the second area there is one more inductor pad is there. So you will notice there is an extra layer of copper that is being added across the inductor pad. But in exhibit A, it is not done, but in case of exhibit B, it is being done. In the exhibit B, you will notice the copper area is broader. The copper area is broader. Now you will notice the distance between the two terminal of the capacitor is being reduced in case of exhibit B. So in case of exhibit B, the distance got reduced. This distance I'm talking about the distance between the two terminals, because as the if the copper is too much in this area, if the copper is too much in this area, then the effective distance between the between both the pads reduces, and at high frequency signal the switching node will definitely cause some kind of an array capacitance. So both the copper will act as the plates of the parallel plate capacitance, and it will increase the value of capacitance. So this stray capacitance will be induced, and because of this stray capacitance, the operation of the power inductor get reduced. So in my opinion, the exhibit B should not be used, and exhibit A is something that we need to use in case of the inductor pads placement. Thank you for watching this video. In today's lecture, we have discussed about the importance of output inductor and the placement of output inductor, and what are the various factors that included while placement of the power inductor, output inductor. Okay. In next lecture, we are going to discuss more into the placement of capacitors, what are the decoupling capacitors, and what are the applications of decoupling capacitors. Thank you for watching this video. Please subscribe to my channel, as I can see most of you watches my video but doesn't subscribe to it. Please subscribe to my channel and like the video, if and please share the video with your friends so that I can provide you free content, and you can request on our community, where if you want any video related to some topics, you can always advise us. Thank you and have a nice day.